question is solve the following equation. Now here we have been given a 2 by 2 or second order determinant. So let us solve this equation. So on expanding the determinant, we obtain x into x minus 5 minus 4 times 3 is equal to 2. We open the brackets, so we get x into x, that is x square, x into negative 5, so that's minus 5x. 4 3s is 12, so we have minus 12. Now transfer this 2 onto the left hand side, so we have minus 2 is equal to 0. So we have x square minus 5x minus 14 is equal to 0. Now if we factorize the quadratic equation by splitting the middle term, we get the factors as, now minus 14 could be factorized as minus 7 into 2, and minus 7 plus 2 is minus 5x. So this could be written as x square minus 7x plus 2x minus 14 is equal to 0. Simplifying further, we take x common from the first and second term, so we have x times x minus 7 plus, now here we take 2 as the common factor, so 2 times x minus 7 is equal to 0. So therefore we get x minus 7 into x plus 2 is equal to 0. So therefore, if we consider x minus 7 equal to 0, we obtain x is equal to 7. Or if we consider x plus 2 equal to 0, we obtain x is equal to minus 2 or negative 2. So therefore, x is equal to 7 or x is equal to negative 2. Question is, solve the determinant 2 sin theta 1 cos 2 theta is equal to 0 where theta is acute. So let's do the first question here. So we have been given determinant of 2 sin theta 1 and cos theta is equal to 0. Now let us expand this. So we have 2 sin theta into cos theta, 2 sin theta into cos theta minus 1 into 1, so that's 1 is equal to 0. So therefore, now we know that 2 sin theta cos theta is nothing but sine of 2 theta, and we transfer this minus 1 on the other side, so we have is equal to 1. But we know that sine of 90 degrees is 1, right? So therefore, if we compare the two, if we compare these two, we could say 2 theta is equal to 90 degrees. So therefore, theta is equal to 45 degrees, or in radians we could say it is pi by 4 radians. Let's look at the second one, x1 minus 1x. Okay, so the second determinant is x1 minus 1 x is equal to 0. Okay, now let's solve this. So from here we get x into x, that's x square, minus, now minus 1 into 1, that's minus 1 is equal to 0. So we have x square plus 1 is equal to 0, or we could say x square is equal to negative 1. Now minus 1 could be replaced by iota square, right? The imaginary unit. Because we know that iota square is -1. So therefore, we have x square is equal to iota square. Therefore, the value for x is plus or minus iota. Here we have to prove determinant of 22, -17, 7 and 1 is equal to 3 times determinant of 5, -6, 7 and 1. So let us evaluate the left hand side first. So in the left hand side we have the determinant with elements 22, -17, 7 and 1. Now if we expand this, we get 22 into 1 minus 7 times -17, 7 times -17, which is equal to 22 minus, now 17 into 7 is 119 and this negative sign here, so we have minus 119. So we get 22 minus of -119, so this becomes plus 119, and if we add the two values we get 141. So that is the value for the left hand side. Let's go to the right hand side now. Now right hand side is equal to 3 times determinant of 5, -6, 7 and 1. Again we expand this, so we have 3 times 5 into 1, 5 into 1 minus 7 into -6, 7 into -6. So we get 3 times 5 ones are, that's 5, minus 7 into -6 is minus 42. So we obtain 3 times minus of -42, so that's 5 plus 42. So we get 3 times 47. Now if we take the product, again we obtain 141, and hence we could say the left hand side is equal to the right hand side. The question is evaluate, and the first determinant has these 4 elements. So let's evaluate that. The first one, determinant of x plus y, x minus y. The second row has elements x minus y and x plus y. So let us evaluate. So we just multiply these two, we get x plus y into x plus y, which is x plus y the whole square, minus, now x minus y times x minus y, that's x minus y the whole square. Now we could use the formula a square minus b square, okay, or we could simply expand these two, that is also better. So let's expand. So we have x square plus 2xy plus y square, and here we'll have x square minus 2xy plus y square. So if you open the brackets, we get x square plus 2xy plus y square minus x square plus 2xy minus y square. So the x squared terms and the y squared terms, they get cancelled out. So we have 2xy plus 2xy. So the value is 4xy. Let's look at the next one. Question number 2. We have determinant of log b base a1 and then 1 and log a base b. Okay. You have log of b to the base a and 1, and the next row we have 1 and log of a to the base b. Now again we just evaluate, we just multiply these two, so we have log b to the base a into log of a to the base b minus 1 into 1, that's 1. Now here we could use the change of base theorem in both these log terms. So we get log of b upon log of a, applying the change of base theorem, into, here also we could write this as log of a upon log of b minus 1. So log b cancels with log b, log a cancels with log a, and finally we are left with 1. So we have 1 minus 1, so the value is equal to 0.